We have seen one of the biggest shifts now in AI, which is specialization. And that's why we have Ram, which is a core contributor at OpenLayer. And he's going to give us the introduction about the future of AIs is specialized models. So please, Ram, big of applause, please.
Thank you. I know it's a session after lunch, so it might be a little dull, but I'll try to keep it as entertaining as possible. I'm Ram. I'm one of the core contributors at OpenLedger. OpenLedger is a layer 2 blockchain for AI. We enable people to build specialized AI models. Today I'm going to talk about why AI is going to be specialized, that's the future, and why we don't think that generalized models are so useful. Let me start with the first mode. So there are three major components of AI, right? We all know about this. Anyone who's looking into AI, there are three components that is very important. The one is compute, second is data, the third is the algorithm or models. It happened about 2 to 3 years back that NVIDIA had so much compute which could be used by players like OpenAI and Meta Llama and so they could build models which had a lot of data sets, right? They had a lot of data sets, they had a lot of compute, would enable better models to be built. That transition is just going much more further. I think that we have come to a point where there is enough compute out there. We don't need more compute for training, but probably we would need more compute for like inference. But there is always a need for data, right? All of these models has been built till now have been trained on data that's usually easily available on the internet, where you can scrape out of the internet, get generalized content, and train models which are larger language models which have like general knowledge, right? But there is always need for more and more data to make the models much better. Because the better the data that you provide, better knowledge you provide, the better the model that performs, right? Let's talk about how apps have been transitioning till now. If you take a look at it, most of the apps today that we've seen over the last 10 years use a traditional backend, an application logic, a human-coded application logic, which has information about the product that comes from a database and a logic that enables you to give an output, right? This is slowly transitioning. Apps are switching from going from being a human-driven application logic apps to more model-driven apps, right? A very good example of that is Perplexity, which is an app which is trying to replace Google search, and they're using smaller models, specialized models that focuses to enable more and more better searches for you, right? You can go ahead and ask a question in Perplexity, go on a search on the internet, process it through a model, and then give you an answer, right? So the transition is going much stronger, much faster than we expect. The next generation apps that we would see would need much more models, specialized models, which are smarter for their own purposes. And we would start to see apps switching away from the existing logic, the application logic, and moving towards more model-focused logic. And we would see apps like, for example, an app like a fitness app would use a model that is used for training, a model that can be used for, let's say, your fitness regime, a model that can enable you to plan your diet better than using a general database to give you an answer. But are we there yet, right? But before we talk about that, let me explain to you about how a human and an AI agent or an app are very similar. Humans today, we provide like inputs from our sensory organs to our brain, and we have like a short-term or a long-term memory that helps you navigate and make decisions. And then we actually make our organs go ahead and execute that, right? Agents are very similar and apps are very similar. AI apps today have an input from a user, process it through their brain, which is an LLM, and use RAG as a memory to go ahead and guide it to actually execute a certain task. It could be on a platform, it could respond to you on WhatsApp, or it could respond to you on Twitter. An agent or an application uses this flow to actually respond to you. But most of these agents and apps today use a larger language model. A larger language model is predominantly trained on internet data that is found on the internet, which is very generic, right? But they're not good enough. As I was telling you, most of the apps that we interface today, most of the services that we interface today cannot provide you a complete solution just by using a generalized model. It needs a model which is specialized. It needs a model that is trained on specialized data sets. As humans, how we would go ahead and reach out to a surgeon if we want to do a surgery, not go to a general practitioner. We would always want to use a model or a brain or a knowledge base which is much more specialized than the existing large language models that is there. OpenLedger provides a framework that enables these models to be built at a scale. These are some of specialized models that are being currently used across the globe, which outperform than ChatGPT or any other platforms out there, right? These are models that are fine-tuned on existing larger language models. For example, there is Bloomberg GPT, which is a much better finance model than any existing ChatGPT applications out there. We provide a framework that lets you build specialized model by having users contribute data sets. And as they contribute data sets, as this model gets built and used, we want to make sure the data contributors get reward as part of the process. Think of us too as an orchestration platform that enable users to come forward, build models with us, and then reward the stakeholders as they start to build the model. We are a layer 2 that is hyper-focused to enable this to happen. Let me talk to you about the platforms and the products that we have and how we make this happen as well. There are 5 major components that we use. The first one is a model proposal platform. This is the platform where users go ahead and propose the models that they would like to build. These are AI models that can be proposed on top of OpenLedger. Users can go ahead and tell people what they want to build and seek for data sets they want to get be contributed, right? This is the platform where users mention the model name, what is the purpose of this model, what kind of data sets they want to collect, and so on. So as these model gets proposed, data contributors go forward and contribute data sets to these models. In this case, we're showcasing a model as being built on top of it, which is a Move model, which is built on Move-based data sets, and they're collecting programming-based data sets like just code descriptions, answers related to the code, and documentations as well. So in this particular platform, users contribute data. Once a model is proposed, data contribution happens, and this is where the data contribution goes on as well. And once there is enough data, the model developer uses our no-code platform called Model Factory. Choose any base model that they want to go with. It could be Llama, DeepSeek, or any other base model, and then start to fine-tune their model with the data sets that they are collecting. And this platform enables you to train using LoRa fine-tuning. It's an iterative platform. Once you start training model with the data sets you collected, you can test out, you could evaluate this model. If it doesn't work out well, you could train again. You can do this as an iterative process. The last piece, which is a very important piece, is the deployment layer. A lot of people build models. If you go to Hugging Face, there's 1,000+ models that's being deployed and built right now. But one of the biggest problem is the GPU cost, right? The cost to deploy a model on one single GPU is exorbitantly high. So we worked with our partners like Aether and built this framework where you can have a model launched in a modular way, right? What do I mean by that? A model runs on a base model, and then a specialized model is a fine-tuned layer on top of that. So anyone who's built a specialized model on top of OpenLedger, they could go ahead and deploy their base model in one single GPU and then attach their fine-tuned layers. All these are adapters. All the specialized model fine-tuned layers are additional adapters that are attached to this base model that is running in a single GPU. So about 100+ specialized models can simply run on one single base model that is running in this single GPU. So what it lets you do is to enable you to launch models at much more lesser cost than running one single model in one single GPU. The last piece is the attribution layer, where we enable users to launch their model on our platform, have these models distributed through OpenLedger, and have them accessed by agents, apps, or end users as well. As these users infer on this model, pay for this model, the revenue goes back to the data contributors. We provide an attribution layer on which users can figure out which data set of theirs contributed for a model's output, and then know it on chain that they're getting paid for it. They know it on chain that they're getting attributed for it. This is our attribution layer that lets model developers showcase how a data is being used, and data contributors can view how the data being used by a model as well, and they can see how much they're getting paid as well. Many projects being built on top of OpenLedger. If I talk more about that, this is the stack, which is our OpenLedger's layer 2. We have built purpose-built for AI, which enables the data contribution to be on-chain, the model development to be on-chain, and the attribution to be on-chain as well. All of the three components that lets us provide rewards to the data contributors are on-chain. Users can go ahead and contribute data knowing that they own the data, only the hash of the data is on-chain. The model developers, as they create the model, they own the IP to the model, but the version of the model is on-chain. And the attribution happens as the data is being contributed, as the model gets used. We figure out which data costs for the model's output, and then we show that on-chain that this particular data costs an output, and then we reward them on-chain as well. So this lets programmers build models and get paid for developing the model on us, and data contributors to get paid as part of the process as well. There are many more models being built on top of us. These are some examples. I'll walk you through about top 4 models that we are quite excited. The first one is a data intelligence layer. This is built by an ex-Google DePIN person. And think of this to be an internet model that is trained on verticalized internet data. It's a data availability layer on OpenLedger, which can enable more models to use this model to build their own use cases as well. We have a team which is building a DeFi model, which is focused on on-chain data sets and off-chain sentiments as well. It could enable DeFi apps and agents to be much better than using a larger language model like OpenAI or Llama, which are much more generalized. And then we have a team which is building a DePIN model, the model that is trained on DePIN data sets. This is the weather-based DePIN model. It's built by a company called Ambios, and they're building this model that can enable better weather-based predictions. And the last one is a Solidity model. It's a model that is trained on Solidity data sets. If you take a look at programming models like Cursor, they're pretty much trained on top 30 languages across the globe, but they don't understand Solidity, right? Because Solidity is a specialized language, not many people know about it. This model is dedicated for Solidity. It's going to enable more and more Solidity-based agents, copilots, and audit agents to use this as well. These are trained on Ethereum-focused Solidity programming language, smart contracts, codes, and code descriptions as well. Lastly, I would like to finish my overall slide to showcase that we're creating the YouTube movement for AI, right? If you take a look at when web happened, a lot of people needed content on the web. And like if you take a look at YouTube, for pre-monetization of YouTube, there's not really good content. But once they started monetizing, you had data contributors as a concept that was born. YouTubers was born as well. YouTubers were able to create better content and post it on YouTube. You had businesses that went ahead and contributed content to YouTube as well, knowing that they could monetize it, right? Very similarly, in OpenLedger, we want data contributors to contribute data. We want businesses to come forward and contribute their data as well, which can enable better AI models. It's a purpose-built layer 2 that focuses on enabling more and more users to come together, contribute with data, and build models, and then reward them as part of the purpose as well. And we are currently in testnet, going mainnet in about 2 months' time. We have 10 plus models being built on us. Work with one of the largest enterprises like Walmart, Viacom, and many more as well. We're soon going mainnet, so would love to get your feedback. Anyone who's building in the AI space, exploring models and specialized models, would love to talk to them. If you guys are building agents and you're looking for models which can help you guys out, I can put you in touch with my team as well. It was nice talking to you guys. We're funded by one of the prominent VCs and angels in the space, Onchain Capital, and many more backed us. We're quite excited on what we're building. We're soon going TG. We'd love to meet you guys soon once we launch. Thanks a lot. Thanks a lot for the opportunity. See you guys soon.